Okay, here we go. All right, so as we mentioned, triangles, yes, three sides, yes, three angles. Okay, quadrilaterals. Okay, think about the word quad. What does quad mean?
Four.
Means four. Okay, and laterals is kind of like a way of saying what?
More sides.
Lines or sides. Okay, so four sides. Now there's specific types of quadrilaterals that we have. Okay, what if you recall when we did if I have something like this, a square. Okay, when we did triangles, we had tick marks like this. Okay, what would that indicate in this particular shape, Dylan?
That all those sides are the same.
All the sides are the same, right? Okay, so even if they don't show four right angles, but we'll go ahead and put the four right angles here. Okay, this is just a what? A square. Okay, if we have one that looks like this, not like that. Well, I know squares are difficult, but you'll be okay. All right, so if I have something like this, okay, would I have this kind of tick marks? Why? Because they are not what? They're not all equal. So why might I have something like this? Dylan?
Because the two dashes are the same and
These are the same and these are the same, right? Okay. And with this would be a what? A rectangle. Although technically these are kind of interchangeable. Okay. What if I have a figure that looks, let's say, like this? Okay. If these are all the same, okay, but what is the difference between this and this square? All these sides are the same. Jada? Right. These both these angles are obtuse. Both these angles are acute. There's no right angles, are there? Okay. So what is this thing called? A rhombus. Okay. All right. What if I have a figure, and I'm going to have to just draw this one with lines. Okay. If I have a figure that looks like okay, let's say it looks like this. Now, sometimes you might see this, meaning those sides are the same, but you also might see a, like an arrow. Okay, so if I saw like an arrow going like this and an arrow going like this, then say an arrow, two arrows like this, what do you think that means? What do you think those arrows mean? Kylie? Yeah, those sides are parallel, okay? So when I see an arrow here, that means this side is parallel to this side, okay? And I see two arrows here and two arrows here. What does that mean? Those two sides are what? So those two sides are parallel. So this, with all that parallel stuff, what do you think this is called? This has two sets of parallel sides and two sets of parallel lines. So this would be a parallelogram. Okay, parallelogram. All right, with me so far? Okay, two more that we might see. I'm going to erase some of this stuff up here. All right, if I have something like this, okay, do you see any parallel sides? Do I see any equal sides? I don't see anything. So what do you think this is? This is just a quadrilateral. The only thing I can gather from this shape is it has four sides, right? Okay, that's just a quadrilateral. Okay, now the last one I want to show you. Okay. Do I see any equal sides here? No. But if I see this, what does that indicate? This is one set of what? parallel lines. So if I have one set of parallel lines, this is not a parallelogram because these two are not what? Those two aren't parallel, but these two are parallel. What do you think this is called? Trapezoid. Trapezoid. Okay. Are you with me so far? Easy stuff, right? Okay. So let's move on to if I'm going to find the measures of any kind of a quadrilateral. Okay, and it doesn't matter. Let's just say I draw just a quadrilateral, no specific type. All right. If I was to draw a line connecting one side to the other, one diagonal to the other, like this, what did I just form? I just formed two triangles, didn't I? Okay, and what did we already determine? What are the measures of a triangle equal? So basically I have two triangles here that equal 180, so what do these together equal? 360, okay? So all quadrilaterals, okay, and it doesn't matter which classification of quadrilateral you have, okay, all of them, the sum of angles write that down. Sum of the angles equals 360. Okay, so let's go back to this one and let's say that we had some angle measures here. Okay, let's say this one was 120. You know, I'm going to erase these 180 so I don't want to confuse you. Okay, let's say this one was 120 degrees. Okay, let's say this one was 81 degrees. Let's say this one was 65 degrees, and this one was just B degrees, okay? So think back to when we did triangles. What are we going to do in order to find that missing measure? What do these three things have to add up to? Dylan? 360 equals, and then I'm going to write what I know. Okay, what are the three angles that I do know? What's this one? 120 plus what? Plus 65 plus what? 81 plus what? Plus B. And I don't know what B is, but I can combine these, can't I? Okay? What's 120 plus 65? 185 plus 81 would give me what? We can do it over here. 185 plus 81. Okay? What would this be? 6. What's 18 plus 8? 200 and... Okay, so this would be 266 plus B. Now, how do I get B by itself here? Bowman? Those were given to us. We didn't have to measure them. You'll be given 3 of the 4 measures. You just have to find that missing measure. Okay, so how am I going to get B by itself? Get rid of what? Jordan? Okay, so if I take away 266 from here, and I take away 266 from here, what am I left with? 94 equals B. And this is a missing what? Angle, so I'm going to label this as 94 what? Degrees. Okay? Does that make sense? That's not that difficult, is it? And it doesn't matter what kind of quadrilateral you're looking at, although all of the quadrilaterals I put on your worksheet, except for one, are just quadrilaterals. Okay? Make sense? Yeah? Okay. All right, so the next part is, of course, solving. We already solved for the missing angle. When we did triangles, what do we also solve for? X, right? Okay, so we're also going to solve for X. Okay, now these look super complicated, but they're not that bad. Okay, if I have a quadrilateral that looks like, I don't want to use the dot. Let's say I have one that looks like this. Okay, and let's say that all I'm given, let's say this is 100 degrees. That one's easy. Let's say this one is 58 degrees. But this one is 7x minus 18 degrees. And this is 5x minus 20 degrees. Okay. Lots of stuff here, but do you think we're able to solve for x? What do I know about this quadrilateral? All of those, regardless of what I'm given here, all of those when I put them together have to equal what? 360. So I'm going to write that out. So 360 equals, now, I can write all these out, and if you want to write all of them out, that's fine. Or I can start combining them before I put them over there. Does that make sense? Can I combine 5x and 7x? What is 5x plus 7x? Does everybody understand what I did there? Okay, so 12x. Okay, can I combine 58 and 100? Well, let's do something a little bit easier. Can I combine 100 minus 20? What's 100 minus 20? 80. And then 80 minus 18 is what? 62. So I have 62 plus 58. What's 62 plus 58? 100 and what? I don't know. I'm gonna do it up here. Okay, 2 plus 8, 0, 7. Yep, you're right. So plus 120. Basically, all I did here, guys, is I kind of combined these steps. Now, if you want to write it all out and do it that way, I'm totally fine with that. Okay? But basically, what I've done is I've shrunk this down to a what? What is this thing? A two-step equation, right? So what do I need to get rid of over here? I got to get rid of this 120, right? So I subtract 120 from here, and from here, what am I left with? 240 equals 12x. Well, how do I solve this? Divide each side by what? By 12. And if I didn't have this 0 here, what would this be? 24 divided by 12 is what? But I do have a 0, so I bring that back down. Now, is this going to be degrees? No. All I have to do is solve for x on these. Okay, does that make sense? Looks super duper complicated, but it's really not that bad. Okay, you want to try one on your own? Let's see if you get it right. Good. Am I giving you a choice? No. Okay, so try this one. All right. When you get an answer, this one's tricky. I want to see if you can get it right. Okay, this is 60 degrees. Okay. This is 2x plus 2 degrees. This is 4x minus 35 degrees. Sorry, 36. And this is 3x minus 8 degrees. Okay, let's give this one a shot and see. Raise your hand when you get an answer for this. If you're still working, keep working. But let's go ahead. Here's what I'm going to do. I'm going to combine everything that I know. Okay, first of all, I know these are going to equal 360. 2x plus 3x is 5x plus 4x is what? Go ahead. 2x plus 3x is 5x plus 4x is 9x. Then I have a negative 36 and a negative 8. What is negative 36 and negative 8? There it is. Sorry. No. Okay, so let's take a look at this. Now, first of all, can I combine 60 plus 2? Yeah, what's 60 plus 2? 62. Now let's get rid of 8 from that. What's 62 minus 8? 54. And what's 54 minus 36? 18. Good. So this is what I'm done. Now, again, if you want to write it all out, I'm totally fine with that. But how many of you got 360 equals 9x plus 18? Okay, good. What's my next step to get rid of what? Minus 18 and minus 18. What is 360 minus 18? 342 equals 9x. Well, I got to divide by 9 here. I don't know what 342 divided by 9 is, so I'm going to do this the old-fashioned way. How many 9s go into 34? 3. And what is that? What's 34 minus 27? How many 9s go into 72? So what's x equal? Degrees? No, just x equals 38. Okay? Make sense? Now I didn't put any on your worksheet that are this hard. I just wanted to make sure you could do this. Okay? Question? Oh, no. You don't need a calculator. We did that without a calculator. We're good. Hi.
Do you have a calculator for the
Probably not. You won't need one. It'll be easy. Okay, let's get started. I'm going to pass out your worksheets.